Okay, guys, so we're going to work through the final lesson of chapter 2. So you should have your notes out right now, and you should turn to page 17, which should be the last section of your notes packet. Today, we're actually going over something you guys were already introduced to in math 2. It's just been a while, and it's a concept that people usually need a few passes with before they feel pretty confident with it. So we're going to be working on completing the square. This is something that we were introduced to last year when we were given an equation of a parabola in standard form, which is what we see right here, where we have x squared minus 2x minus 15 versus graphing form, which I wrote down right above it. So graphing form has the a, h, and k, and the goal is to find a way of going from standard form to graphing form kind of like quickly. The way we were introduced to how to graph a problem like this, in terms of finding the vertex, again, if it's in graphing form, we know the vertex, it's h and k, and we know the a value. Here, though, we do not know the vertex when it's in standard form. The way we first learned how to find the vertex of something like this is to first find the x-intercepts. So if you remember, a parabola has symmetry. So if I know the two x-intercepts, then I know that the vertex has to be right in the middle of those two x-intercepts. So we can find the x-intercepts here by setting this equal to 0 and solving this quadratic. This is a quadratic that factors, so we can go ahead and do that. So if I put my x squared and my negative 15, well, multiplies to negative 15 and adds to negative 2. Turn this, okay. So that's going to be negative 5 and positive 3. So negative 5x, positive 3x. So once we factor x minus 5, x plus 3 equals 0. Okay, don't forget the whole reason we factor is because then if I know the product of two things equals 0, then the only way that's possible is if one of these two factors equals 0. So my two x-intercepts, I can add 5 here, and I get an x-intercept of 5, subtract 3, and I get an x-intercept of negative 3. So I still don't know the vertex, but I do know that the vertex is exactly in between these two x values. So we can average those two x values, so 5 plus negative 3, or 5 minus 3, over 2. So that's going to average, which means find the middle of it. So 5 minus 3 is 2. 2 divided by 2 is 1. So what we know is that between these two intercepts, 1 is the x coordinate of our vertex. So we basically just found our h value. K, we don't know yet. But we can get the y value. What we need to do is plug our x value back in. We have an equation to solve for y when x equals 1. So we just need to figure out what happens when I plug 1 into this equation. So that's going to be 1 squared. Let me write this up here. 1 squared minus 2 times 1 minus 15. So 1 squared is 1. Minus 2. So 1 minus 2 is negative 1, and then minus 15. So altogether, we get negative 16 for our y value for the vertex. And then the a value, that is the one piece of graphing form that is visible in standard form. It's still just the coefficient of x squared. So in this case, the a value is 1. So now we have our a value, we have our h and k value. So now we can go ahead and put it in graphing form. So the equation in graphing form would be a, or 1, times x minus h squared minus k, or plus k, which is negative 16. So this is how you were first introduced to going from standard to graphing form. Does this strategy work for every equation? So if I wanted to start the same thing here in standard form, I can see a equals 1. When it comes to my intercepts though, and I would have to set this equal to 0. And then we would ask ourselves, when starting the factoring process, what multiplies to 10x squared and adds to 8x? So the only two numbers that multiply to 10 besides 10 and 1 are 5 and 2. So no combination of 10 and 1 will equal 8, and no combination of 5 and 2 will equal 8. What this means is this is not factorable. So can we find those clean x-intercepts and average them to find the x-coordinate of our vertex? Not very easily. We could use quadratic formula, but that's pretty time consuming. So this is where you guys were introduced to this idea of completing the square. So completing the square is the process of rewriting the equation of a parabola in graphing form by forming this perfect square piece. So x minus h squared is a perfect square. And that's what we are going to build as we complete the square. So we're actually going to continue with this equation from part B right here, x squared plus 8x plus 10. So to complete this square, imagine algebra tiles. So we're just thinking about our x tiles first. Let me just rewrite our equation, x squared plus 8x plus 10. So when we are completing the square, our focus is on the x terms, x squared, which is already a perfect square, and then 8x. So this plus 10 right here, we just kind of want to put it aside for now. So we're not going to focus on that. So in order to put it aside, I'm just going to subtract 10 from both sides. And we are left with y equals, oops, no, we're not. We're left with y minus 10 equals x squared plus 8x. Now, this is what we want to complete the square on. So it says area model right here because I'm going to sketch an area model for x squared plus 8x. So we want to build a perfect square. Right now, this is not a perfect square, but x squared is a perfect square. So if I'm setting up an area model like we normally do with x squared down here, and then these are typically these two corners are typically combined to form our x term, so 8x. But if I want a perfect square and x squared is already perfect, then I want to split these 8x's evenly so that the dimensions of this area model are a square. So that would be x times x, which means this would have to be x plus 4 times x plus 4. So these three boxes, x squared, 4x, and 4x is what we already have. It's not a perfect square until we fill in this last empty corner, but that's going to be 4 times 4, which is 16. So to complete this square, I'm adding 16 here, and now this is all a perfect square, but I have to make sure I add 16 here. So when we see what happens here, the result is negative 10 plus 16. So y plus 6 equals, and now instead of writing x squared plus 8x plus 16, since it's now a perfect square, we can write it as those dimensions squared. So x plus 4 squared, and then all we have to do is subtract the 6 back over, and we have x plus 4 squared minus 6, and now it is in graphing form. So x plus 4 squared minus 6. Now we have our h and k. So our vertex is at negative 4 comma negative 6. So we can graph that, plot the vertex, and then we can see that our a value is 1 from both of these equations. So that means I'm going to go over 1 and square it. Over 2, 2 squared is 4. And then we can graph this parabola. So hopefully this is feeling familiar and easier than the first or second time you guys have seen completing this square. All right, so what I want you to do at this point is pause the video, like actually hit pause. I want to put it in graphing form by completing this square. So I want you to pause and then finish the problem. I will also finish the problem and then you can check your work. Okay, so hopefully you have paused and worked through completing the square for this on your own. And the first step there is just moving the 9 over, so subtract 9 from both sides. Then I did the area model, and we had to complete the square by adding 4 to both sides. Then we can rewrite this, so x squared plus 4x is now a perfect square, which you can just rewrite as x plus 2 squared, and then that final step of adding the 5 over. So you end up with graphing form of this parabola x plus 2 squared plus 5, which means our vertex is -2, 5. And then you can graph that parabola there. Okay, so completing the square. Now the next problem is a new application of completing the square. So this is kind of like the next level of completing the square. So if you look at this equation, x squared plus y squared, so this is, we're throwing in a y squared here, so that's going to change things. Plus 4x minus 8y plus 11 equals 0. What type of graph will this produce? So I don't expect you guys to actually look at that and know it. However, this should look a little familiar to you from the last lesson that we did of transforming non-functions, and we found that this is the equation of a circle. So this equation, x squared plus y squared plus 4x minus 8y, this is actually the equation of a circle. It just doesn't look like it yet. So we need to turn this equation into this graphing form of a circle where we have the h and k and the r for radius, and the center is going to be at h comma k. So h comma k is what we need to know for the center, and the radius is just r. So once we have a number there, we can just find the square root of it to find r. Okay, the challenge here is that we have y terms and x terms, but if we look at our equation, the equation of a circle is just 2 perfect squares. So one perfect square formed out of the x terms and a second perfect square formed out of the y terms. So you're just going to be repeating the process 2 times, once with the x's and one with the y's. So if I rewrite our equation down here, I'm not going to rewrite it exactly as we see it here, because if I'm completing the square on my x terms, then I want to put my x terms next to each other. So I'm going to write it like x squared plus 4x. And then I'm going to put my y terms next to each other, y squared minus 8y. So plus y squared minus 8y. And then this 11, just like the first step up here when we're completing the square for a parabola, is move that 9 over. That's what we're going to do with this 11 too. So right now we are not concerned with the 11. So I will just subtract it to the other side. So this will be equals -11 for now. Okay, then just looking at my x terms. So these right here, I want to complete the square on those. And then we'll have a perfect square formed with x's. My 4x's evenly, so that's going to be 2x and 2x. So right away, I know my dimensions of my x perfect square, they're going to be x plus 2 times x plus 2, which means to complete the square, I need to add 4. So that means it's going to be x squared plus 4x plus 4. But if I add 4 to this side of the equation, I also need to add 4 to that side of the equation. Okay, I will rewrite this in a moment, but now I want to complete the square on these y terms. So I'm going to do the same thing. I'm just going to use the letter y. So I have y squared minus 8y. So I'll start by putting y squared down here. The negative 8y's need split evenly. So it's going to be -4 and -4. And then my dimensions are obviously going to be y times y for y squared, -4 here, so y minus 4 times y minus 4, which means in order to complete the square on my y terms, I need to add -4 times -4, which is 16. So I need to add 16. So my y terms are now y squared minus, 8y plus 16, but I have to add 16 over here as well. So that's going to be equals, so now I have -11 plus 4, which is -7, plus 16. So all of this now adds up to 9. Okay, so don't forget the whole reason we just completed the square on the x's by adding 4 and on the y's by adding 16 is so that instead of writing it like this, I can now write it as a perfect square, x plus 2 squared. Same with the y's, y minus 4. So these all simplify to y minus 4 squared equals 9. So what we have is the equation of our circle now in this graphing circle form. So our our H and K and our radius are all a piece of that equation. So remember the center is the H and K value. So whatever's being subtracted from X is H. Since it's X plus 2, that means we would have to be subtracting -2. So the center is going to be -2, comma, K, which is 4. So then we can plot the center of our circle, -2, 4. And then the radius, so since the equation is r squared on the right side, 9 is the radius squared, which means the radius is the square root of 9, which is 3. To graph a circle, once you plot the center, you can go up 3, down 3. So you can just go 3 unit. Oops, that was only 2. 3 units away on like directly up, down, left, and right. So it kind of looks like a rotated square. But then you just do your best to sketch in a circle with those 4 points. So that is how you take the equation of a circle in standard form and put it in graphing form by completing the square 2 times. Okay, the rest of this is just practicing completing the square. So at this point, you can stop and pause the video and complete the square on A and B, which are both pretty straightforward. On C and D, so these two are a little more challenging. Don't forget that just because you have an odd number of X terms, it doesn't split in half neatly. It's not going to be a whole number, but you can still complete the square. So you're still going to do the same exact process. You're just going to have decimals involved. Part D is a little extra tricky. I'll probably walk through this one. But before you watch me walk through that one, I want you to pause the video. I will pause my recording, finish these problems, and then you can check your work with my answers of these. I want you to work through them, so please do not just skip ahead and jot down the answers, like actually pause, work through, and then I will walk through this one before I end the video. Okay, pause now. Okay, so hopefully you have worked through these bottom 2 on this page, and I'll talk through them really quick. So here is the part A. This is the solution you should have gotten, y equals x plus 3 squared minus 2. So if you need to pause it, check your work right now, make any corrections you need to. And then on part B, you end up with this equation here. Again, you can pause the video, check your work, find where you messed up if you didn't get the same thing. And then on the next page, we have part C, this one where you're splitting the x term of 7, which means when you complete the square, it's 3.5 and 3.5. So the perfect square is x plus 3.5 squared. And then you complete the square by adding 12.25 to each side. Subtract the 10.25 back over, and then you're left with this. Okay, this very last one, I'm hoping you at least tried it yourself for part D. This one is different. Hopefully you noticed that what makes this one a little extra challenging is we have this 3 in front of our x squared, so that's our a value. So let's start this the same way we would any other one. So the first thing I'm going to do is subtract this 11 over. Remember, f of x is just fancy function notation for y. So I'm just going to subtract the 11 first. And then I have 3x squared plus 12x. So we can still complete the square on this. Visualize what 3x squared is. That's going to be 3x tiles or 3x squared tiles. However, if you notice from both of these terms, 3 and 12 are both divisible by 3. So the first step here is, let's just think of this as 3 times x squared plus, and then if I factor that 3 out of the 12x, turns into 4x. So we have 3 times x squared plus 4x. So all I did was just factor out this 3 from both of those terms. Now what we can do is complete the square just focusing on those x terms, x squared and 4x. So that we can do. We can do a quick area model, x squared, and then we're splitting 4x's evenly. So it's going to be 2x and 2x. So our perfect square here can be formed by completing the square by adding 4. However, I'm not actually just adding 4 here. What's happening is if I add my 4 plus 4 and then move that parenthesis over. So if I'm completing the square inside these parentheses on these x terms, what I actually just did was add 4 3 times. So this 3 out front, when we distribute that to the 4, what I actually just did was add 12 to that side. So instead of adding 4 to complete the square and then adding 4 on this side, that plus 4 is actually adding 12. So that means I need to add 12 to this side as well, which means now we have y plus 1 equals 3 times. Now I can write x squared plus 4x plus 4 as the perfect square dimensions of x plus 2 squared. So the a value of 3 is still right out front. Then we can just subtract the 1 over, and now we have this parabola in graphing form. 3 times x plus 2 squared minus 1, and my vertex is -2, comma, -1. Okay, hopefully this was not too much of a stretch from what you guys remember from last year. The only new thing here is just practicing it with other types of graphs like circles, and splitting odd number x's, and then this sort of challenge situation where you've got an a value that's not 1. Okay, that gets us through all of chapter 2. I'll see you guys in class next time.